Right, so welcome back. So in this video, we are going to look at how to find missing rainfall data. Now, we have several methods that we are going to use, but here we are going to focus on these two methods. That is the station average method. Station average method. Then we are also going to use the normal ratio method. Normal ratio method. So in simple terms, let's say there's rainfall readings or recordings due to one or two reasons at a particular station within a basement or a catchment or a watershed. We couldn't get the data due to either the individual taking the data is sick, or there is a disaster, or the person forgot to go and take the data at a specific point in time, or the individual or the professional supposed to take the readings, they are on industrial action, and so many other situations. So what we do is that we have several methods. We can use the interpolation from isohedral map. We can use the station average method, and we can also use the normal ratio method. Now, the station average method, we can say that that is the what we call the arithmetic mean. So we can see that this is the arithmetic mean method. The arithmetic mean method. We can see that the normal ratio method is the um, Bayesian or the Bayesian method, right? So yeah, so basically we just want to find the data of a missing rainfall, right? So let's go into the question. So one of the four monthly red rain gauges on a catchment area develops a fault in a month when the other three gauges recorded. So let's say rain gauge one. So let me rain gauge one. I'm using PA to represent rain gauge one. The rainfall was 37, right? And it is in millimeters. Then rain gauge B, the rainfall was 43 millimeters. Rain gauge C, the rainfall was 51 millimeters respectively. Now the average rainfall for these gauges, so the average rainfall, so let me see, average rainfall for um, station A is 726 millimeters. The average rainfall for station B is 752 millimeters. The average rainfall for station C is 840 millimeters. And the average rainfall for the missing, I'll represent it by M, for the missing um, station, or the station that within that particular month we didn't get its rainfall readings because it was 40. I'm represented by M. For that one, the average rainfall is 694 millimeters, right? Now, what is the formula? So now I'm looking for the rainfall for the 40. Now, you see, because we didn't get it, because it was 40, we actually did not record. So what we are going to do is that we are going to interpolate. So this whole thing that we are going to use the data that we have for other stations and use it to interpolate that for the missing or the broken one. Do you get it? And so here we are going to use the normal ratio method. The normal ratio method. So they estimate the missing monthly precipitation at the latter. So then we are going to use this method. Now, among these two methods, this is much accurate compared to this. So the normal ratio method is accurate compared. So what's the formula? So the formula for the missing is equal to um, the sum of the rainfall divided by their corresponding annual rainfall times So this whole expression multiply the average, the annual rainfall of the missing station over the number of stations that are working. You get it? So PI is um what we call rainfall at given station for a particular month. Now PAI is their annual rainfall. PAVM is the annual rainfall for annual rainfall for the missing liter or 40 beads. Then N is number of number and affecting normal number of working station, the station that are working at that particular month. Are you okay? All right, so let's take the question. Let's take now, after explaining, let's solve this. Let's solve the question. All right, so we are going to have this. So we are going to have from the formula that we just saw, sorry, times. So first of all, we need the average for the missing, which is 694, over the number of stations, which is 3. 3 stations are the state 1, 2, 3. These stations are working, right? Times. So the sum. So each station, the what we recorded for the month divided by its average. So 37, its average is 726 plus 43 times its average 752 plus 51, its average is what? 840, right? And so if you evaluate this, you're going to get, so with it, you're going to get 0.16885932411. And so this is going to give us what? 39.0627 millimeters. It means that the rainfall for the 40 inch at that month, if the gauge was working, we are going to get the rainfall to be around 39.0627 millimeters. And so that will be it for this question. Now let's take the other. All right, so let's see the second question. So we have rain gauge station D was inoperative for part of a month during which a storm occurred. The storm rainfall recorded in the 3 surroundings are, so rainfall for station A is what? 8.5 centimeters. Rainfall for station B is 6.7 centimeters. And rainfall for station C is what? 9.0 centimeters. If their average rainfall at their station, so the average, let me see, for A is what? 75 centimeters. The, the average annual, the average annual, the average annual for B is 70 centimeters. And the average annual for C is what? 90 centimeters. Now they said using both methods. Oh, I think I've missed it. Oh, sorry. The average for A is 75, B is 84, B is 70, and D, that would be the missing, the inoperative station, the average annual rainfall is what 90 centimeters. Now estimate the storm rainfall at D using both the average and the normal ratio. So I told you that we have two methods, the station average. There are three, but this is what we are going to focus. So the station average and the normal ratio. Now the station average, the formula for when you are using the station average, the formula is um simply the sum of the various rainfall over the number of station. This is what the station average method. Station average method. Then the normal ratio method is the rainfall for the missing, the annual rainfall for the missing over the number of stations, working stations, please, multiplying the sum of the rainfall per month over the average annual rainfall for their respective station. So they say we should use these two methods. So if I want to find the missing, that is for D, using the station average method, is simply the sum of the rainfalls over the number of stations that is working. So the rainfall is 8.5. So it's going to be rainfall of A plus rainfall of B plus rainfall of C over number of stations. That will be 8.5 plus 6.7 plus 9.0 over what? Over 3. Please note 4. The N is the number of working stations, right? So it is 3, not 4. Let's take it. So we are going to get, let me find it out. Let's see. So we are going to get 8.067 centimeters. Now, if I want to use the other method, that is normal ratio method, I'm going to use the normal ratio method. Then it's going to be the average of the D over the normal number of station times the sum of the individuals over their average annual rainfall. That is this. So in that case, 90 over 3 times what? 8.5 over 75 plus 6.7 over 84 plus 9.0 over 70. And if you do the evaluation, you're going to get what? 9.65 centimeters. Now, when we use the station average method, this was the rainfall that was supposed to be recorded. If we use the normal ratio method, this is the rainfall. So I told that this is more accurate. The normal ratio is more accurate. So in a question where they are asked to use the most accurate method, always use the normal ratio method. Thank you for joining us. And the next time we meet, we will look at other methods. That is we look at the mean rainfall method, the isoheater method, and the Kizun method. Thank you very much for watching. Make sure to like, share, comment, and subscribe to our YouTube channel, Educate Foundation. Also care for you. Bye.